Present on automated UI testing on Firefox OS.
Hi people. So today we are gonna talk about automation, automated test case, and more specifically end-to-end automated test case. That is to say, tests that are running on devices like this and which are performing exactly the same actions as a user like you, me, Martijn are able to do. So before going further, I'd like to just remind a couple of things about UI automation. So our end-to-end testing find regressions on a daily basis. So we have builds every day, like the nightly on Firefox desktop. We have also it in Firefox OS. So it helps in finding, regressions that happened since yesterday. Like I said just before, it simulates user interactions and helps in reducing the manual testing, mainly for two reasons. The first one, it's faster. The machine is faster than the user, just in response time. But the second one is we have many manual test cases for Firefox OS, about more than 5,000. So we are trying to automate this kind of things. Also, UI automation helps in finding regressions, especially the two main components of Firefox OS. Gecko, which is the same engine as in Firefox desktop, and Gaia, which is the front end. We have about 400 commits combined. So there's a lot of activity, and sometimes a commit that happened that is supposed to fix Firefox desktop on this platform is breaking Firefox OS. So we're trying to catch that. And before going further, just to know a bit each other, because we have about an hour to stay together. Just to know who here is familiar with automated testing, like unit test, integration test, cool. And who is more familiar with Selenium-like testing, like testing website? Awesome. So this presentation will be, we'll try to cover first UI automation for beginners, and also we are going to explain some specifics for Firefox OS. So people who are used to Selenium should have something to discover during this presentation. So first, as a reminder, Martijn will talk about the WebDriver API and Marinette, which is, you're going to discover that. And then why Firefox OS is a bit different from a regular website. Coming from that, we found some test practices and we'd like to share out. And finally, how we test like every day and nearly on every commit at some point. It's not done yet, but we are getting at on regular device. So that's the program for the next hour. Welcome everybody.
Okay, yeah, I don't need a microphone if it's correct, so it should work. I'm going to talk a little bit about the WebDriver API and Marinette, basically. So the WebDriver API is more or less a W3C standard, and it's based on Selenium. And well, I personally haven't used Selenium myself before I was involved with Firefox OS, but this is basically used by many people, and it's used for website testing, UI testing basically. And since Firefox OS is based on, well, HTML5 and CSS and JavaScript, it's basically all the apps are like HTML pages. We from Mozilla thought we could use a Selenium-based API for that basically, and that has become Marinette basically. So, where do we use Marinette for? it's not only used for Firefox OS, we are also using it for Firefox desktop nowadays, for browser.html and for the body up app. So how does Marionette work? So basically, yeah, you have your own machine, you have plugged in your Firefox OS phone. Then we have the Marionette client, which is like a Python package which you have installed on your computer, which is communicating with your Marionette server, which is embedded as part of Gecko in this case, because like in this case we have like a special engineering build it's called, basically, which has Marionette installed, which allows you to interact with your Firefox OS phone and which allows you to simulate UI actions. This is not something that you have on your regular phone because yeah, it can be a security issue if you have something like that on your regular phone. So this is only used in engineering builds, basically. So the Marionette server is basically communicating with Gecko, and that is basically steering the Gaia and the system app and all the apps that are on your phone, basically. So what does Marionette do? So, well, if you're familiar with basically with Marionette, you can interact, you can access HTML elements, you can interact with them, you can click, long press, and you can inject scripts by using execute script, and you can do screenshotting, which is actually very convenient if you have like failures, for instance. So we use screenshotting when we have failures in our test, basically, so we can see basically what's going wrong. If we get a failure, like if the test is successful, it's actually not so interesting, basically, because that's actually the expected state of a test, of course. So now I'm going to show you basically an example of Marionette, so how we in general use it. So we can basically start a Marionette session on the phone by using self.marionette start session. You can access an element by using find element. This looks pretty much similar to Selenium, I would think. In this case, we are trying to access an input element. So you use find element, you access the input element, and then you send some text to it. Basically, you try to fill the text input. In this case, we use send keys. So send keys is like a function that's directly putting text in this input instantly. But there are also, like in the case of Firefox OS, you have the virtual keyboard, of course, which you normally as a user would type from. So if you would write a UI test correctly, then you basically would first go to the virtual keyboard and then type some text by just typing the M and then the Y, etc., the space. So it would be a little bit slower. So in this case, we took a shortcut, but we also have tests that basically test the virtual keyboard by going through the slow path, basically. And afterwards, so yeah, as you can see, this is a test basically that tries to send an SMS. So afterwards, we try to click on the send button. Well, in this case, it's a tap because on a mobile phone you tap on the send button. So that's what we do. We try to access the send button, and then we tap on the send button, and then the SMS is basically sent. So this is like very basically how like a Gaia test is working. Basically, there are some more steps involved, but yeah, this is the basics. Really. So to access an element in Firefox OS, you first have to find out you have to find out how can you access this element. So normally you can use CSS selectors for that. But in order to use that, you have to find a way to know this element has this ID or this class selector. And in order to be able to do that, we use Web IDE. That's basically used to navigate through the DOM of this Firefox OS. Well, the thing is with Web IDE, we can use that because Firefox OS is basically built off a whole bunch of web pages, basically. So we have the system app, which is a HTML page. And under the system app, we have a whole bunch of other apps, like the home screen, which is an HTML5 app, and the contacts app, for example, or the browser app. They're all HTML apps, basically, and with HTML apps, if you're familiar with them, they all consist of elements, basically, and they consist of a DOM. So with Web IDE, it's easy to access the DOM and to see the contents of the DOM, and that's basically what we use, basically. So the system app is in its own process, and then we have all the child apps. The home screen app is a child app of the system app, and all the other apps are basically also. And they have their own process, basically, which means if the home screen or contacts app or the phone is crashing, then it doesn't mean the whole system is crashing, it's only the app that's crashing. And it means when it's crashing, the system app can decide, oh, we're going to restart this app or whatever. It just means your phone is still usable, except that app is at that moment not usable, but can be restarted, basically. And it's also a way of basically increasing the security of the operating system. It means if there is a security issue with the browser or within the phone app, it doesn't mean the whole system is in danger, basically. So I can show you basically a demo of how Web IDE works. It's a very convenient tool to see basically the contents of the operating system. So in this case, I'm starting up the SMS app, the Messages app, and now I'm using the click to find an element feature. So I'm clicking somewhere on the phone, somewhere on an element on the Messages app, and try to find that element. And then the Web IDE automatically shows me the contents of this element, basically. It shows me the ID, the class name, etc., and also the DOM underneath it. And Web IDE is also, it's even more powerful. You can also change the DOM, you can add stuff, but in this case I'm deleting stuff, basically, because it's very easy to delete stuff. Adding stuff is a little bit more difficult. But you can also copy the whole DOM, or there's also a feature to find the unique selector, basically. So if the element in case has an ID, then of course you try to use the ID to find the element in your test case, basically, in the automated test you use. But if the element you use doesn't have an ID, then you can use the unique selector tool in Web IDE to find a unique selector for this particular element you try to access, basically. that's actually, I have to go back. So yeah, what are our common practices which we use in Gaia UI automation? So Marionette is basically a kind of it's kind of similar to Selenium, but like in this case, Selenium is just not enough. So Marionette is not enough for what we need to do for our UI testing on the phone. We also need to have some file and process management. We need to be able to push some files like videos and images. And we also need ADB features. We need to be able to stop the B2G process, restart the B2G process. We need to be able to add preferences, settings, and that stuff. And that's just not part of Marionette itself. So we added this as a layer above Gaia test. And yeah, like we also need some more interaction with our Gaia system basically. So we also need the ability to inject scripts directly into Gaia. So there, like Marionette has can do quite a bit, but we are still lacking in that sense. We still need some extra features and context and that stuff. So we can also do execute script in that case if we need to add DOM properties or things that Marionette can't do. So that's what we use if Marionette is basically lacking. So what happens when, basically when a test is being run? So we basically have our test. This is basically the test is using the Marionette client API or the Gaia test API. So if it's using Marionette client, then it goes directly to the Marionette server, and then it gets part of Gecko, and then it goes to Gaia and sending the commands to all the apps that you want to use. In the case of Gaia test, and it can do commands basically directly to the ADB server, and then goes to the ADB daemon, and from there to the gong layer, and then goes up there basically. I think now Johan is taking over.
So we're just gonna explain a bit more what is hidden behind this box called Your Test. So as people familiar with Selenium, we started with the page object pattern. So this pattern is about abstracting what you see on the UI. So basically, for each HTML page you have a page class that represents it and represents what the user can do. For example, your let's say on the login page, you expose how to fill the login, the password, and how to enter these credentials. So basically, the test is not aware of how to do things. It just asks for doing it. And pages also instantiate the next page. For example, once you correctly logged in, you go on the home page. So the test retrieves the next page class of an instance of the next page class, which represents the home page. So we started with that, and we came across some issues. So Firefox OS is composed of many apps, and some of these apps share common code. For example, we have headers. So in every app, the header is the same, modulo some options. For example, in the SMS app, once you want to create a new SMS, you can go back, and this go back is exactly the same code in every app. So this exists, and we also started to centralize this part of the behavior, like it's done in the production code. So in the production code, they use something called web components, which are custom HTML elements. And this part is actually a bit tricky because it sandboxes what's inside, and this regular Selenium API doesn't. I'm sorry. Selenium API does require, but it's not exactly like switching between a regular iframe. It's switching into something called the shadow DOM. So you have to change the root element in order to see exactly what's embedded in this web component. So we started to specialize the page class into page regions, so like it's done regularly in websites, and also we started to add for every single widget that is shared all across the OS. So we have the headers. We have, for example, the every checks. So every checks every checkbox and a radio button. We need that because we sometimes have some race conditions happening. For example, you have the checkbox for the Wi-Fi, and it takes like up to, let's say, 10 seconds to be in a usable state. And we wanted to centralize that because it's not the only button that has this particularity and that requires to be in the enable state. So instead of repeating that in every page object, we extracted that. So let's see an example of how to run this send SMS test as we talked about. So, like Martijn said, we actually tap on the keyboard that is displayed. So it's a bit long like this, but it's still less long than doing it manually. And then we wait for the SMS to come back. So we actually send the SMS to ourselves. Ooh, that was too fast. Okay. So you all know when you receive an SMS from yourself, I guess. So usually in test we do first set up the environment. In the case of the phone, we have much data that can interact with the phone. So in order to make sure that we are in clean state, we delete all the data at the setup. It should have been done in the tear down. The problem is when you receive the build at the beginning, it's already set up with some data that we don't want. So we have to clear that up at the beginning. Then we set the known settings and preference. In Firefox OS, there's a difference between a setting and a preference. A preference is a handle at the gecko layer, whereas the setting is in the front end. So we set both. We restart the device because sometimes Gecko doesn't pick up a preference that has been set. We push the data, we launch the app, then we do something with the app and check the results and clean up when it's at the end. Even though the cleanup is not really needed because we already knew everything at the first step, but we just want to feel good with our test, say, okay, we actually did the good cleanup. So, for example, this SMS we just sent is currently this code. You can see it in GitHub, so it's just exactly the same code. So as we said, we have this class called Gaia test case. So this is a part of the Gaia test that Martijn presented just before, and does all the setup on the device. Then we launch the app. This should have been on the setup, by the way. We create a new message, and we retrieve the phone number from the device here. We send a text message. So as you can see, the text contains a timestamp. We do that because sometimes SMS arrive like 5 minutes later, so they basically pollutes the next test because of the carrier. It might sound weird, but sometimes that happens with T-Mobile in the US. So we just timestamp that in order to retrieve the right SMS. So we create it, we send it, we wait until we've received it from the carrier, we retrieve the representation of this text, and we assert that, of course, the text is exactly the same. So thanks to the page object pattern, the test is almost doesn't need any comment. We have like about 7-8 line of codes. Whereas if, just as an example, if we did it without any awesome. So without any abstraction around that, here's what the test could have looked like. So we create a new message, we put the phone number, we type the message, we send the message, we wait to make sure it arrives, we retrieve that, and then we do the assertion. So, here's the idea. Now I can show you some type of abstractions. So for example, this very handy create new message is here. We support actually many recipients. So type phone number does exactly what it is. So it first taps on the header to make sure the focus is right in the correct thing, correct input. Sorry. Then Martijn said we use the actual keyboard displayed on Firefox OS. So we also abstracted that thanks to another page object. So the keyboard here enables us to do all the mapping and tap on the correct app. So here it is, and create new message back on it. And then here we return this page class, which represent the new message. As you can see here, we have to do something a bit particular. So the transition happens, as you could see from there, and we have to make sure that the new message panel has arrived at the leftmost position. So this is mainly due because all the panels you see are inside the exact same HTML page. So Marinette doesn't have the on node finished event to wait on. So we have to perform our own waits here. And that's about it for the test. If you want to see more details, it's published on GitHub, and the link will follow right after this presentation. So to finish, how do we actually execute tests once they're written? So here we have a test that is working perfectly on my machine. How do we scale up in order to have that running for at least once a day, and next once every comment? So there's a mess at platform because right now we're in migration phase. We still have the old architecture and trying to move forward to a new architecture. So we're gonna present here both of it and what was the reason behind switching. So as many projects, we use Jenkins at the beginning. So Jenkins, this is the current state of our Jenkins. It doesn't look good, but this is mostly due to some intermittent issues that are due to the hardware and external dependencies. So, for example, we have the FM radio, so we support FM radio on this device, and sometimes we don't manage to get any radio channel. So that's something we're trying to get a control on. We tried a couple of solutions like a signal amplifier and that kind of things, but we still have sometimes this kind of failure happening, and this is not a race condition in the code, in the production code, not really something that we forgot to wait on in the test, even though that happens quite often. So yeah, that's something we're trying to fight against. So as you can see, we have many jobs. We have jobs for every branches we have. So we have the master/central branch for Firefox for Gecko, but we also have two integration branches, which are called Mozilla Inbound and B2G Inbound. B2G stands for Firefox OS. That's a good name. So we also monitor that these three branches in order to know, in order to help finding regressions. For example, if Mozilla Inbound has failed first, you know that the commit comes from there. Whereas if you only monitor central, you would only know once every merge. Every merge from, I mean, you would know only if you would know only it happened, but you wouldn't know if it happened in the B2G branch or the Mozilla Inbound branch. So we have that. We also have different types of jobs. Because they take long to run. For example, the smoke test takes about an hour and a half. We also have some extra tests that are not considered as smoke tests. So we try to parallel that once every build comes. So that's why we have many jobs. And there's also one job that does nothing except waiting on the home screen to appear. We call that the brick test. It's because sometimes we have very bad comments that happens and entirely blow up the lab. So, for example, the phone are not able to replay anymore. They have a kernel panic and they're stuck with a white screen which drains out the battery. So. So this kind of things can spread very quickly if you don't have a gatekeeper first, and this is the type of jobs we have, the break job. We verify that the phone is not bricked. So here's a bit more of details behind our Jenkins instance. So like I said, our builds are not made in Jenkins itself. They are hosted somewhere else and built at some other places. So the master node is in charge of monitoring when a new build is available, then downloading it, and then triggering the other downstream jobs. So we have about 25 slave nodes, and on each of them are attached either one or two devices. So in our lab we have a pile of Mac Minis, where on every Mac Mini we have a one or two phone plugged. So on the slave node it happens exactly the same thing as if you were on your computer. So Jenkins solved this job distribution very easily like it's all embedded in the system. However, we had a couple of issues. First, the lab doesn't scale well. Each time you need to add a device or two devices, you add a new machine, which can be a bit smarter. Also, our instance is, we are an open source company, but it's behind a VPN, and few people have access. So at the beginning, it was more just to prevent our devices from being corrupted or used at some other purposes. But it turned out to be more of a hassle than something we could rely on. And especially if you wanted to contribute in our test suite, well, the only way to know that it works is by running it on your computer and wait the next day once it's merged in the repo and make sure that this hasn't break anything. So this was a very problem that we could have solved just by removing the VPN, but there's something a bit more problematic. At the beginning, we just added new jobs thanks to Jenkins UI. So we clicked on it and we duplicated, we copied a new job and that kind of things. And he didn't scale very well, and it led to much duplication between jobs. For example, if I wanted to add a new type of test, well, I can end up modifying like 10 to 15 jobs just to make exactly the same modification. So there are some ways to fix that, and I know there was a session in the automation dev room, and it ended like 20 minutes ago about how to scale up Jenkins, but that wasn't the solution we chose. Mozilla has a place where all the tests, end-to-end included, are being run, and this place is called TreeHerder. And basically, we have exactly every job for every platform that is represented here thanks to a green ladder, an orange ladder, or something more bad, red. So our goal was to add these more jobs that you can see rounded in blue, just to have more people to just to enable the report, make it more fancy to access rather than connect to the VPN and go to the test presence report. So that was one of the reasons we changed our architecture and used something that is more common at Mozilla. So we have, like I said just above, TreeHerder, and we have Task Cluster. So Task Cluster, as its name infers, is something that spawn and execute tasks in a big number. So we have the build task. We have our test task. So basically, our job was has been to add a new type of test task. Which and now we don't monitor every new build. We are actually triggered by the build task being done. So the test task doesn't own anything. It's actually a Docker instance somewhere on an Amazon instance. So we don't have any more Mac minis to pile up and plugs devices in. We instead we have a vendor that helped us to build a device farm and give us this reverse proxy, which helps in retrieving a device, flashing the right bill on it, opening all the ports. So we talk about ADB, we talk about Marinate port. So set everything up for the devices farm we have. And as we spun many tasks, we centralized all the authentication system directly in a proxy. So basically, tasks are totally agnostic of how to connect, how to flash a device, how to connect a device. They just receive something from the proxy, a port to connect to, actually 2 ports to connect to Marin and ADB, and then run the task. So here the architecture is a bit more complex, but each component has its own job. And finally, the workers here is just a monitor job that verify how many devices we have available. We have different type of configuration. For example, 0 SIM cards, 1 SIM cards, 2 SIM cards in this device. So we have each worker for we have 1 worker for each type of configuration, and the worker makes sure that this kind of configuration is available, and then wakes up a task created by the build task once it's ready. So the test task has nothing to do about retrieving any job. So this architecture is still work in progress. We have some jobs available and publicly visible, but as you could see in the previous slide, it's still orange, so we have to fix a couple of race conditions and that kind of things for, in the end, having everything visible. And finally, this task cluster plus trigger architecture helped us in having a build for end-to-end testing for every commit happening. So we don't have to wait anymore on nightly builds from commit. So that's about it for the architecture, and we have 10 minutes left, as the girl in the back tells us. So do you guys have any questions? Comment? Yes?
Two questions. How long does it take to build?
So the question is, how long does it take to make a build? So I mean, you mean? So the first build, like the actual build to make Firefox OS takes about, on task cluster, something like 30-40 minutes, and then the tests themselves take about 20 minutes. So yeah, you should have your results in about an hour plus, depending when you have race conditions. So the question is, do you test happy path or do you test more of edge cases? So for end-to-end test, we try to keep only happy path, and because it costs a lot, and also, let's say you can't send an SMS anymore. Like you see it on the device. Why? You don't really learn a lot of information when this kind of tests fail. So that's why it's preferable to have more unit tests and more integration tests in the middle. So that's why also we don't really test edge cases, because the debug would take too long to be effective. And also, we implement happy path just to make sure that people still can send an SMS, even though we don't know why it can't. Yes?
Do you still have around, did you say 300 or 400 commits in a day? Was that the benchmark that you are, and if it takes that long to build for every commit, is there a lot of queuing going on in your build system?
So the question is, do you still have about 400 commits every day? you do, how is the queuing done for the builds. So so we have a bit less comments in Gaia recently. Gecko still has about the same because it still empowers Firefox desktop. And the queuing part is done mostly by the workers. So if no device is available at this time, the test tasks are not spawned. So we queue them there. So we have the build task create more and more tasks and test tasks, and then the worker wakes them up one by one. So that's how the queuing system is done. Yes.
So is this the big task cluster installation, or do you have a smaller, basically own task cluster system? And if so, how easy is that to set up to get your own task cluster set up?
So the question is, do you use the big task cluster instance that Mozilla has, or do you have your own instance, and how is it to set up your own? To be honest, we only use the Mozilla's one, and when we have to debug task configuration, there is something on the task cluster UI that helps you creating tasks. So we have a layout for this particular task, and we just change a couple of things in there. So then we have a task that is off the record coming on Trigger, so you can debug it on your own with your own results, and nobody nearly notice it. However, it uses the same queue system, so if you spawn too many, well, some people might wonder why task doesn't show up anymore on Trigger. Is there any other question? Well, thank you for listening, and happy testing.